In this lesson, we are going to learn about the polar representation of what? Complex numbers. So, given a complex number z to be equal to x plus iy, okay, where x is the real part and then iy is the imaginary part. You can write this complex number as z equals what? X comma y. Okay, so in this case, you consider x and y to be what? The coordinates of a plot. So which means that you can plot x and y here in the what? In the complex plane. Okay, so let's look at how you're going to do that. So I have this graph here where I named this the real axis. Okay, and then this is the imaginary axis or the positive y axis, or this is the positive x axis. Okay, so you can plot the complex number z here. So let's say this is the x value and then this is the y value. Okay, so when I plot z, let's consider z to be somewhere here. Okay, so this is z. Okay, so that's the plot of what? Z. Okay, so with this plot of z, you can find what? The modulus and then the argument. Okay, so when I measure the distance from this origin here to the point of plot, okay, that distance will be known as what? The modulus, okay, of the complex number z. And then this modulus is often represented with the symbol absolute value of what? Z, or with the symbol what? R. Okay, so you can represent the modulus with this symbol here or what? R. Okay, so you see that what this line here makes an angle with the positive x axis, okay, which is this angle that I name what? Theta. Okay, so this angle is known as what? The argument. Okay, so therefore the argument is the angle that the line joining the origin to the point of plot makes with what? With the positive x axis. Okay, so with these values, let's look at what we are going to do. So this side is y and then this side is what? X. Okay, so I'm going to take the cosine of what? The angle theta. Okay, so that will be the cosine of the angle theta will be equal to what? The adjacent. And in this case, the adjacent side is what? Is the x over the hypotenuse, which is what? The modulus. So I'll use what? R. So I would like to make x the subject. So that gives me what? X to be equal to what? R cosine of what? Theta. Okay. So from here, I'll take the sine of the angle. So that was sine theta will be equal to what? The opposite. And then the opposite side is what? The y value here. So that was y over what? Hypotenuse. That's what? R. So therefore, if you want to make y the subject, you have what? Y to be equal to what? R sine of what? R sine of what? Theta. Okay. So now let's look at how you're going to calculate for the what? For the modulus. So for the modulus, which is the distance of this line here, okay, we can apply what? Pythagoras theorem. So you have what? R squared equals x squared plus y squared. So to make R the subject, we're going to what? Square both sides. Therefore, you have what? R to be equal to what? The square root of to be equal to the square root of what? X squared plus y squared. So this is what? The modulus. So if you want to calculate for the modulus, this is the formula that you will use. Okay, so now let's go back to z. We know that what? Z equals what? X plus what? Iy. Okay, but we know that what? X equals what? R cosine of theta, and then y equals what? R sine of what? Theta. So let's do direct substitution here. So therefore you have what? Z to be equal to what? X, which is what? R multiplying what? Cosine of what? Theta, and then plus iy. But in this case, y is what? R sine of what? Theta. Okay, so you see that what? R is common to both the cosine and then the sine. So let's factor the r out. So we have what? Z equals what? R outside the bracket, then you have what? Cosine of what? Theta plus I sine of what? Theta. Okay, so we call this the polar form of a complex number. Okay, so this is the what? Polar representation of what? Of a complex number. Okay, so we are given a complex number and then you are asked to represent it in a polar form. This is the formula that you are going to use. Okay, so you have to what? Find the modulus and then you find what? The argument. Okay, then you come and substitute into this formula and then that will help you represent that complex number in what? In a polar form. So let's try some examples. So given the complex number, let's say z equals what? 5 plus 2i. Okay, so we have this complex number here. So you have to represent this complex number in what? In a polar form. Okay, you have to represent this complex number here what? In a polar form. So let's look at how you're going to do that. So the 5 here is the x and then the 2 here is what? Is the y. Okay, so before you can continue, you have to what? Solve for the what? The modulo. So that was r is equal to the square root of what? 5 squared and then plus what? 2 squared. Okay, so that will equal to what? The square root of what? 25 plus 4. Okay, so this will be equal to square root of what? 29. Okay, and that will be equivalent to what? 5.39. That's converting it into what? Two decimal places. Okay, so that's what? 5.39. So now you know the value of what? R. So what else do we need? Now what we need is what? Is the argument. Okay, which is what? The angle, the this line here makes it what? The positive x-axis. So to do that, we can take the tan inverse of what? The y and then the x. Okay, so when you take the tan inverse of what? Y and x, we can find what? The angle here, which is what? The argument. Okay, so we have what? The argument theta to be equal to what? The tan inverse of what? The y over what? Over the x. So when you're doing this, you don't consider the signs of what? The numbers. So let's say if you have -5 here and then you want to write it here, you're going to ignore the negative. Okay. So now let's find the argument. So this is what? Theta equals what? The tan inverse of what? Y over x. In this case, y is 2 and then x is what? 5. So that will give me theta to be equal to, so tan inverse of 2 over 5. Okay, so that gives me theta to be equal to what? 0.381 radians. Okay, so that's what? 0.381. Okay, that's in radians. Okay, you can convert this to degrees. So you get this answer in degrees. Okay, so this value in degrees will be equal to 21.8 degrees. Okay, so you can either write your answer in radians or in what? In degrees. Okay, but I'm going to use the answer in what? In radians. So now we know theta and then we know what? The modulus also. So now let's come back to this formula here. Okay, so you can write the complex number z, which is equal to what? 5 plus what? 2i in the polar form as what? Z equals what? R, which is what? 5.39. Okay, so that's what? 5.39. Okay, multiplying what? Cosine of what? The argument, which is what? 0.381. So cosine of 0.38, cosine of 0.381. Okay, plus I sine of what? That same angle. Okay, let me clean this so I can have some space. Okay, so that's what? Plus what? I sine of 0.381. Okay, 0.381. 181. Okay, so this will be the polar representation of this complex number here. So now let's try another example. Okay, so we have the complex number z to be equal to minus 4 plus 4i. Okay, so this is the complex number that we have. So you have to write this complex number in what? In a polar form. So first of all, you have to solve for the what? For the modulus. Okay, so to solve for the modulus, that what? R will be equal to what? The square root of 4 squared plus what? 4 squared. Okay, you can leave the negative sign here when calculating for the what? For the modulus. That will be equal to what? The square root of what? 16 plus 16, which will be equal to the square root of what? 32. Okay, so that will be equal to 4 root what? 2. Okay, so that's the value of what? The modulus. So in order to know the value of what? The modulus, we have to what? Calculate for the what? For the argument. But before then, let's plot this complex number in the complex plane. Okay, so this is the real axis, and then this is the what? Imaginary axis. Okay, or this can be the positive x, this can be the positive y, and then this is the negative y, and then this is what? The negative x. So if I'm to plot this, I have what? Minus 4 here, and then I have what? 4 here. Okay, and you know this is the first quadrant, this is the second quadrant, this is what? The third quadrant, and then this is what? The fourth quadrant. Okay, so with this, we are going to use a simple formula here. Okay, so since the plot lies in the what? In the second quadrant, you can use the formula theta, okay, which is the argument to be equal to what? Pi minus what? The tan inverse of what? Y over what? Over x. Or if you want your answer to be in degrees, you have what? Theta to be equal to what? 180 degrees. Okay, minus what? The tan inverse of what? Y over what? Over x. So you can use this formula here to find what? The argument. Okay. So you can use this formula here to find the argument. So in this case, let's say we have what? Z here. Okay. So the argument will be this angle here. Okay, so that what? The angle from the positive x-axis to what? To the line here, to this line. So that was the argument. So in this case, the argument for this complex number here, I like the answer to be in what? Radians. So I'll use the first formula. So that what? Pi minus what? The tan inverse of what? Y over x. That's what? 4 divided by 4, and that's what? 1. Okay, so we have what? The argument to be equal to what? Pi minus what? The tan inverse of what? 1. Okay, so that gives me the argument to be equal to what? 3 over what? 4 pi. Okay, that's radians. Okay, so if you want your answer to be in degrees, you can use this formula. Okay, so that what? 180 degrees minus what? The tan inverse of what? 1. Okay, so that gives us what? 100 and what? 35 degrees. So if you used the second formula, this is the answer that you get. Okay, and then if you use the first formula, this is the answer that you will get. Okay, so now we know the modulus and then the argument. Okay, so now let's come back to these formulas here. Okay, so I'm going to clean this. So the complex number z, which is equal to what? Minus 4 plus 4i. Okay, we can write it in the polar form using the formula z equals what? R multiplying what? Cosine of theta, okay, which is the argument, okay, plus I sine of what? Theta. Okay, so therefore z will be equal to what? We know R to be equal to what? 4 root 2, okay, multiplying cosine of what? the argument, which is what, 3 over 4 pi, okay, plus I sine of what, 3 over 4 pi. Okay, so that's what, 3 over 4 pi. Okay, all right. So this will be the polar form of what, this complex number. Okay, so what this means is that if you simplify this polar form here, you will get these values here. So let's look at that. Now let's multiply 4 root 2 by what, cosine of what, 3 over 4 pi. So 4 root 2 times cosine of what, 3 over 4 pi. Okay, so this will give me, multiplying 4 root 2 by this will give me what, the value of what, minus 4. Okay, so let's multiply this with what, the sign. That's okay. So when I do that, also that give what, plus what, 4i. Okay, so you see that what, you can convert from what, rectangular form to polar form, and then you can convert it back from what, polar form to what, rectangular form. So that's what polar representation of what, complex numbers means. Thank you very much for watching this video. Please don't forget to like, subscribe, and then share.